This is section 5.1 for calculus. The topic is finite sums. As we begin second semester and we start into chapter 5, we're going to start into integral calculus. Up to this point we've been focusing on derivatives, and now our focus is going to shift. And so when we talk about integrals, as we move forward, we want to keep in mind, just like with the derivative being the slope of the tangent line, we constantly want to think about we're looking for the area under the curve. So a lot of our area formulas that we already know are going to come into play. Now, the rectangular approximation method is when we take a bunch of rectangles and we find their areas and we add them all together. And we use that to find the area under the curve. Now, if we think about the area under the curve of the velocity function is equivalent to the distance traveled over a specific amount of time. So you can see now, instead of going from position to velocity, we're going backwards. There's three methods. There's the LRAM, RRAM, and MRAM. And L is for left, rectangular approximate left hand. R is right hand. And M is midpoint. Okay, and we will kind of talk about these and how they show up. And the formula that we use is the area of each rectangle is equivalent to the function at x sub 1 times the width of each rectangle. And this is the change in x, which is the width, but it's the same for all rectangles. So our heights can change, but our widths are always the same. And if we take all of those areas of all of those rectangles, it equals the sum. And that gives us the area under the curve. So, for example, an object moves at a constant rate of 3 feet per second. Find the distance traveled of the object after 4 seconds. Well, we know that distance equals rate times time. So if we draw this, a constant rate of 3 feet per second means that I have this line going through here, through y equals 3. Here's my function. Now the question asks, what happens after 4 seconds? So at 4 seconds, I get this nice rectangle. Well, I know that the length of the rectangle is 4. I know that the width is 3. And so I find out that the distance equals 3 times 4, which is 12 feet. So that's how far it traveled. And that gives me the area under the curve. And I can do that for any size rectangle, any size function. The problem is that sometimes velocity is not constant. So our example is t plus 2. So what happens if I draw this guy? Well, my graph does something like this. So when I try to find, say, what happens at 3, I get this sort of odd-shaped area. Well, when I have this odd-shaped area, I can then break it into smaller rectangles. Here's a rectangle, here's a rectangle, here's a rectangle, and you see I have 3 rectangles. Now, it's called the rectangle approximation method because it's not going to give me the exact value. This would be an example of a right-hand rectangle approximation method because the point of my rectangle is on the right corner of each rectangle. That gives me my height. Notice how each of these has a unit of 1. So my delta x is going to be 1. But then I got to figure out where my right hand is to find my areas. And we're going to do an example of this in class so you can actually draw some rectangles and see what this looks like. But keep in mind, that's the right one. what happens if I show you the left. So with my left rectangle, here would be one, and notice how my point's here. The next one would come up here, but it would go this way. So there's my left. Next point's here, coming this way. And here's my left, and you can see how the right hand gave me an overestimate, where the left hand is going to give me an underestimate of what the area of my rectangles are. So your homework is page 271 through 6 all. We will go through in class how to do the rectangle approximation method, and you're going to use this on your homework. If you need to, you can go back and watch the video again. This video is more about the big picture idea and what we're trying to do. So I break my rectangles, the area under my curve, into rectangles, find the area of each rectangle, and add them together.